All right, everybody. Hey, welcome. This is all about Webassign, looking at forces. This is 7.1 forces. Big thing coming out of this is Fnet equals MA. It's all about the net. Okay, there's the first idea. Next, always draw a force body diagram of your situation. So that always start with that. What are your forces going on? Next up, weight force equals mass times gravity. You'll use that throughout this, knowing what a mass is in kilograms, and gravity is 10 meters per second squared on Earth. If you have a problem that's dealing with the moon, they'll usually tell it to you. It's 1.6. If they tell you Mars, they're going to probably tell you it's like 3.7. Okay, I don't know for sure, but it's something like that. Go to Jupiter, it's a lot, so you'll get squished. So knowing that, as we tackle these problems, we want to think about what are the forces involved. Next up is that we notice that if you pull with, say, 12 newtons, and you pull backwards with 12 newtons, if you pull the same forward and backwards, two things could happen. It could either be at rest, or it could be going constant velocity. Okay, so that is a big idea, that when the forces all cancel out, so that you're either at rest or going constant velocity. So knowing that, we're going to dive in. Let's just get after this. Start with number 7. Ones before this are, I want you to think about what's going on with the forces. I want you to try it until you get it right. The inclines, we'll talk about that a little more, but think about it. When you're on an incline, what are the only forces acting on you? Okay, so 7. So you have 250 kilogram mass. It's accelerated. So we're going to apply a force to it, normal force, and we have a weight force. Now in this problem, they don't say there's any friction. There's no reason to believe there is, because they kind of infer there isn't, kind of. It's kind of a weird way of doing it, but they give us an acceleration. So if I do F net equals MA, my mass is 250 kilograms, my acceleration is 3.5. Plug in a calculator, you get a number. Okay. If the mass is doubled, okay, what happens to the acceleration? So if I apply a force, if I make my mass bigger, my mass goes up, my acceleration goes down. I'll go down by a factor of 2 because it's not squared. All right, let's get after this. We got number 8 coming up, people. So on this one, it's a single force, no friction. What's the acceleration? Using F net equals MA. My F net is only 8. Because I have no friction. And so I get an acceleration of 2. Okay? So that's kind of our build-up ones. So now we're going to start getting some good ones here. So now we have a graph. It's like, oh my gosh, you got a graph. You're going to be okay. So we got ourselves a graph. Looking at number 9 here, number 9. And so on this graph, so notice that there is a line. It's linear. So I'm going to find the slope. Slope of this graph is going to be force over acceleration. And what you need to do is you need to think about, how do those two relate? Well, F net equals MA. So if I divide both sides by acceleration, I'm left with mass. So that force over acceleration represents mass. So if I find the slope on this, I have the mass. Slope is rise over run, 1.5 over 3. You're done. Next up, number 10 is review. So I have a displacement time graph. Displacement and time. Displacement and time. So I got to think, how do displacement and time relate to each other? The question asked me about velocity. So I go, how do these guys relate? So velocity is displacement over time. So displacement and time on this graph, that would be slope. So if I find the slope of this graph, it's displacement over time, it's a straight line, it remains the same. Now we get into number 11. So in class, we were able to talk about what do we do when we have multiple forces? So if I have 8 going one way, 3 going to the other, if I do F net, my F net is going to be 5. Those two forces are working against each other. So the big one minus the little one, left with 5. Well, F net equals MA. Okay, my mass is 2, get my acceleration. And which way is my acceleration? Whichever way my F net is. And so that is to the left. Okay. All right. Big one, too. All right, big one, too. We got ourselves 40 kilogram mass is moving along a horizontal surface at 5 meters per second. What's the magnitude of the net force required to bring the mass to a stop in 8 seconds? 8 seconds. Boom, we're going to start there. So it's a constant acceleration. We're going to do it in 8 seconds. It's going 5 meters per second. I'm going to stop it. Okay, this is number 12. Okay. What is the net force? I need acceleration. I do not need displacement. So I need acceleration. Well, you got to think, what is my equation without displacement? That is my first equation. So F equals 5 plus A times 8. So I get an acceleration of negative 5/8 meters per second squared. I look on there and I'm like, it's not on there, I'm freaking out. So you do F net equals MA. You look at there, you got a mass of 40, you got acceleration of negative 5/8, and I end up getting 25. 25 newtons. The question is asking for magnitude, so I give him 25, and I cross it out, and I go to the next problem. All right, we're looking at number 13. I want to get you stretching and thinking here. So I have a velocity time graph. So it's asking about acceleration. Well, acceleration on number 13. Who's a lucky one? The acceleration is change in velocity over change in time, which is also the slope of the velocity time graph. So the slope of this graph. So A to B, I have a positive slope, so I have a positive acceleration. B to C, I have an acceleration of 0. C to D, I have a negative acceleration. So people are always thrown off. Well, what happens when it crosses? It's still negative. Even though it has a velocity of 0 between C and D, it's still negative. D to E, we have a positive acceleration. Now it's going to ask about net force. Well, guys, since F net equals MA, which I'm going to put an arrow over this. So the way we symbolize it is vectors, is we say, well, the F net is a vector. The acceleration is a vector. Well, if the direction of the F net is the same as acceleration, they have to be. So because of that, if that's a positive acceleration, that means I have a positive F net. So I have an F net in a direction. Here I have a 0 F net, negative F net. So I would have a reference frame. There's 13 people, big 1, 3. Check that box. We're going to 14, watch out. Woo! 14, part B. Well, part A, we'll do 14, part A. So 14. So we got ourselves a car. Doing this thing. What is the acceleration acting on the car? Well, we got a normal force, we got a weight force, and if it's moving to the right, it's going to have a frictional force to stop it. That's from the tires. If you're on ice, you ain't stopping people. So I got F net equals MA. So I've got F net of 265. Mr. Schmier, my numbers are different. That's on purpose. So I get an acceleration of, on mine, 265 over 1,500. Some of you are going to be concerned about don't have a negative on there. That's okay, because I have arrows and I know direction. So I have 0.1767. It's small, okay? So I have a small acceleration. What's the acceleration? Check that box, okay? What's the car's speed? Aha! The initial, the final, acceleration, displacement, and time. Oh, it doesn't say it's stopping it. Schmier, I assumed it was stopping it. It was not stopping it, it's starting it. So if it's starting it, that means the car is going to be going this way, and the frictional force would be in the direction it wants to go, to the left. So sorry about that. Sorry. So 0, acceleration is 0.1767. Schmier, that's not much. I know. What's the car's speed after 35 seconds? Fast. Okay. No displacement. Solve for it. There you go. Now, get to big 1, 5. Woo, 15 people. 15. All right. Crate rests on very low friction wheels. Ooh, no friction. The crate and wheels have a weight force of 775 newtons. Very important. That's not mass. To get mass, I divide it by 10. 77.5. Okay. Our answers are going to be a little bit off because we should use 9.8. But you pull on the rope with a force of 175. So I apply a force of 175 newtons. Okay. What's the acceleration? Now, if that's the only force pulling on it, then I would just do F net equals MA. Where it's going to get tricky in future problems is what if I have a frictional force backwards? So F net equals MA. F net is 175. My mass is 77.5. I solve for acceleration, and I'm done. How far will it move? The initial, the final, acceleration, displacement, and time. The initial is 0. Starts from rest at the very beginning of the sentence. How far does it go? Plug in my acceleration. How far does it go in 2 seconds? I do not care about V final. So now I'm looking at my last equation. 1/2 AT squared. Last equation is delta x equals VIT plus 1/2 ET squared. So delta x equals 1/2 A. My acceleration, this is why I didn't write it down, because yours are going to be different. So 175 over 77.5. Get 2.2, 2.26. Time is 2. Boom, plug it in, off to the races. All right, 16 just happened, because 16 we're on an elevator. And so an object rests on the floor of an elevator that's moving down. So it's moving downwards in the elevator. So the velocity is downwards and it is speeding up. Well, which way does the acceleration have to be to speed up? It has to be in the same direction. Now, if the acceleration is down, that means my F net is down. Well, if this is my weight force, this is my normal force. If those are equal, I don't have a net force down. So those can't be equal. Well, what does that mean about my normal force? My normal force gets smaller. That's the big idea on the lab around on Friday, the on-demand, about the elevators, is that once you know, hey, is it speeding up or slowing down? That tells you. If it's speeding up, your velocity and acceleration are in the same direction. If it's slowing down, they're opposite. Then once you know the direction of the acceleration, and you know the direction of the net force, the F net, okay? Once you know the direction of the F net, you know which way there has to be more force. Last idea, your weight force doesn't change, but your normal force does. All right, 18, small weather. Did we skip 17? Oh, 17 goes at a constant speed. 17, if it goes at a constant speed, goes at a constant speed, That means my acceleration is 0. That means my F net is 0. That means my normal force and my weight force are equal. And if they're equal, my weight force is 480, my normal force is 480. It doesn't change. Guys, it's actually really important. If you're in an elevator in between floors, masked up, but you're in an elevator between floors, going constant speed, it just feels the same. But if you stand on the bathroom scale where you accelerate, it changes. All right, big one, 8. See, we got 18 and 19 coming up. Here we go, 18, big one, 8. Boom. Here we go, 18, small rocket weighs. Oh, little tricksters, which means the mass is 1.4 kilograms. Don't let them trick you like that. Now, if you get the answer wrong, divide by 9.8 to get a better accurate answer. Oh, look, they gave us a leading question. Part A, 1.4. If they say it's wrong, divide by 9.8. Part B, the rocket fires its engines. Ugh. The rocket has an upwards thrust of 120. Draw a picture, guys, because we're dealing with forces. The weight force is 14. The upwards force is 120. So that means they want to know acceleration. F net equals ma. My mass is 1.4. What is my F net? 106. Why, might you ask? That weight force. Because remember this rocket. Have you ever seen like a spaceship take off? They're called rockets, right? What happens? At first, it just kind of levitates because the weight force is pulling down and the thrusters are pushing it up. When they're equal, it stays at rest or goes constant speed. The upwards one, to get acceleration upwards, you have to apply more force than your weight. So I get an acceleration that, let me solve it really quick. Okay, so now let's see, number 19. Guys, seriously, we all have different numbers. If I write down a number, it's just an insult. So dog with a mass of 5,000, oh good. So the dog has a mass of 5.6 kilograms. It's important because they are saying that there's 4 significant digits. So that means our answer could have 4 significant digits. Sits on an elevator, good little buddy. What's the apparent weight of the dog? The apparent weight of the dog, what that means is normal force. So if the weight force is 5.600 kilograms times 9.81 meters per second squared, I get a very accurate weight force, which is 5.6 times 9.81. I get a weight force downwards of 54.95 newtons. That's my weight force. Now, if I think of dog, nice job, puppy, right? He's got a weight force of 54.94. Well, that means the normal force is 54.94. Basically, if the dog looks down and has intelligent thoughts, I feel like I'm in the movie Up, and you look down, you look at the bathroom scale, it would see 54.94 newtons and go, that is my apparent weight. That is what it looks like my weight is. Do you ever see what your weight is? No. You see your normal forces. Bathroom scales, I could put it up against the wall and hit it, and it'd be like 24. Doesn't mean my hand's 24 newtons heavy. It just means I pushed it that much. So when you stand on a bathroom scale, the weight force is pulling you down, and then the bathroom scale is like, why are you pushing on me? What does it do? It pushes it back on you. So all it's reading is your normal force. So now we get to part B of number 19. The last question of the entire thing is super awesome. The elevator suddenly accelerates upwards. This dog's going to freak out because that acceleration is massive. Okay. So now what we got is we have an acceleration upwards of 9.250 meters per second squared. Just so you know, this dog now feels twice as heavy, but you're going to see what that means. So ready? So we've got ourselves our dog as a weight force moving upwards, accelerating upwards. So that means that the normal force will be bigger. Okay. This is what we refer to as our apparent weight. Okay. Now, F net equals ma. Anytime they give you an acceleration, do that. 5.600, acceleration is 9.250. So for my numbers, I get 5.6. 5.6 times 9.250. Oh my goodness, the pink calculator is about to get retired. I get 51.8. So the F net is 51.8. But the weight force is 50. I want to get this accurate. I don't know where I put that. 54.94 newtons. That's what the weight force is. The F net is 51.8. So the apparent weight is 54.94 plus 51.8. It's both of those added together. So let's think about this. The dog now looks at the bathroom scale and reads 106. That dog feels twice as heavy. This is called pulling G's. This dog feels like it is 2 G's. So when you hear fighter pilots say, dude, I pulled 8 G's. Speaking of Top Gun, can't wait for that to come out. But guys, that's what that means. It means you feel, you have a normal force acting on you that's that big. So when you're in the ISS right now and you experience 0 G's, that just means your apparent weight is 0. They stand on a bathroom scale, they just float, okay? And so that's important. They still have mass, they're still being pulled by gravity, but their normal force is nothing. So there you go. Thanks for tuning in. If you made it this far, go have a snack. You guys are awesome, okay? Go get them. All right, guys, talk to you later.